from our first and our second feedback forms. And then we figured we got a mobile webcam here that we can break out and then kind of look at things as you guys want to.
Sounds great. Proceed.
All right. Eli, you got it pulled up?
Yeah, I'm getting there.
Okay.
Okay. So can everybody see this? Okay. Peyton, I'll let you take over then.
Sounds good. So just a quick outline of what we were kind of planning on doing here today. We'll take a look at our first progress report feedback explicitly. We'll probably jump. There's a couple things that we'll want to address directly with the mobile cam. So anytime we say field trip on here, we'll probably jump back over to the mobile cam real quick and point something out specifically. Then we'll move into the second progress report and we'll address those items. And then after that, we can kind of pull it out to the mobile cam and kind of go over whatever you guys would like to see. Just kind of a status update for us. We have finished the design and manufacturing and we're just in the final cosmetic stages with our rocket. So everything's kind of pulled out of the rocket just for that paint job at the moment. But we have all our components with us at the moment right now. So the feedback kind of topics that we got from our first progress report was identifying a flyer of record, talking about our fin flutters velocity, some of the payload interface questions that we had, our drogue descent rate, and our main deployment altitude. In the next couple of slides, we'll kind of address those individually. So to start, our flyer record, I don't think he's with us today. He was traveling for a NAR event going on in Colorado today, but we did secure a flyer record who will be coming out with us to competition. He is a level 3 with NAR and with TRA, and he's out of the Wyoming High Flyers Club.
Has he been with you guys the entire time or just recently joined?
He's been with us since the beginning of the project, pretty much.
Okay, and he's been actively involved in the design and he's comfortable so far with the rocket?
Correct. We've been looping him in on all our progress reports, and he kind of, we're bouncing questions off of them occasionally. And then we did get the opportunity through our project to meet up with him face to face at our level 1 and level 2 launches for our personal launches as part of the project, and kind of got a good couple hour debrief with him down in Colorado. So he's been involved since the beginning.
That's great to hear.
The next item that we had was our drogue descent rate. It was a little bit slow. I believe the competition said 75 to 150 feet per second. We resized the drogue chute. We scaled it down a little bit, and we're hitting a new simulated velocity of 82, almost 83 feet per second for that drogue rate. And then we had a misinterpretation of the rules on our end. We were deploying above 1,500 feet, and we are adjusting our flight plan to deploy at 1,500 feet or below using our altimeters. And then we were talking about our fin flutter. We'll have another slide after this that kind of goes into a little bit more detail. We were using this equation that you can see on the bottom of the screen to calculate our fin flutter. We didn't generate any MATLAB code or anything. We just pulled this equation out of some of the newsletters that we found online in the out of the kind of sphere of influence, I guess. We had some old material data in it at first, which is what led to a lower flutter velocity. When we got the new material data for this carbon fiber components or carbon fiber material that we have, we got a much higher fin flutter velocity of about 2,500 feet per second. Then we had some questions about the payload interface, so we'll take a little field trip real quick to this mobile cam that we have. I could steal the screen from you.
Yep.
Let's see. Sorry, I'm not the best at Zoom. Where's the that bar? Probably help if I was do that. Sorry, Eli, can you help me out? Do you know how I would switch to this?
To switch your camera, you mean?
Yeah,
So on the bottom left, there's that camera icon.
I didn't see it. There you go.
Okay.
So I'll try not to make everyone sick with this. So this is kind of our payload interface that we have here. This is a 3U CubeSat design. And then we have these two segments of material on either side. At the very ends, we have 3 all threads that run all the way through the length of the payload. And then they're secured with steel eye nuts for use in recovery later on. Inside the payload, we have plates of steel that kind of make up the balance of the weight. And this all thread goes through all those plates as well. So even if we were to lose this cover for whatever reason, the components inside inside that payload would still be retained within the rocket.
How you doing?
Does that make sense?
So quick question on the payload. Can you switch back to the camera?
Yep.
So, all right. So I see the 3, the connection points there. Is this remaining inside the rocket, or are you guys deploying it out of the rocket?
This will remain inside the rocket.
Okay.
Up top, you can you might be able to see it. We have these drilled holes here.
Yep.
That's going to be 4 1/4-20 screws going through the fuselage of the rocket in the nose cone, and we'll kind of point it out in a little bit. That are going to help retain this inside the nose cone so that everything stays together as one piece throughout the launch.
Okay. Those connection points.
Yep.
I have a deep, and this is a personal fear more than anything. What is keeping those from rotating off?
So as it sits right now, there's nothing, but in the final flight configuration, there's going to be a nylock nut here, and there will also be Loctite on the threads of the steel eye nut.
Okay. On the other side, same scenario?
Other side, this whole section of plastic is threaded, and then we do have the nylocks with the Loctite.
Excellent. Okay, that's great.
I think we can go back to that presentation, Eli.
Yep.
So here's just kind of a breakdown of more of the data that we had for that equation calculating our spin flutter velocity. I don't think we need to touch on it too much unless you guys have any questions about it.
I'm assuming y'all aren't going to be going that fast.
No, we're expecting less than 1,000 feet per second for our velocity.
Yeah, the key piece in flutter analysis, particularly on rockets with significantly large motors, is really your Mach speeds and how long the vehicle is going to be in that threshold space where you're talking 1,000 feet per second. Obviously, the faster you go, the stuff starts to heat up, the vibrations will get worse, the epoxy and all the other things that are holding it in get weaker, the cracks start to form, and then we have an event. So the fact that your rocket is very close to but not exceeding means that that window is going to be fairly small. But the flutter analysis requirement is still a relatively new thing for ESRA. This is the second event that we've actually been pushing it pretty hard. But again, as you guys progress in your own personal rocketry careers, when you start designing rockets that are going to be potentially breaking Mach or Mach 2 for that matter, this flutter analysis is super critical. And the strength and being able to design stuff that can support Mach 2, Mach 3, and being in that regime for several seconds is really challenging. So it's good to see you guys doing that. And we're still going to do the old school, grab your fins and squeeze them together as hard as we can. So if they still feel floppy to us, we will still have some challenges there. But again, we've done the math here, and it looks good to me. But the old school is still, I'm going to grab one tip, grab another tip, and I'm going to try to get the two tips to touch. And if I can't do that, then you're in good shape.
Good. So that was the feedback that we had from our first submission feedback. So we'll move into the second report feedback. These are kind of the big topics that were discussed, just kind of talking about what PA6, what that material actually is. We kind of touched already on the fin flutter velocity, so we probably won't touch on it again. Our nominal diameter versus our coupler length, our rail button hard points, the open rocket simulation data, recovery redundancy, and recovery charge sizing. And then we were going to talk about the payload interface, but we kind of, since it was in the first report, we kind of doubled up on it there. So we'll get into the material here after the rail buttons, just because we'll kind of give you a little bit of a preview of the podium session that we put together, since that was our podium session presentation. But we'll move into our coupler lengths. So our nominal diameter on the rocket is 6 inches. The physical OD is 6.17 inches. Per the rules, that would be a coupler length of 12.34 inches. Our couplers are sized to 12 inches off the nominal diameter. So just wanted to bring that up and address that.
No worries, that's good. You're in good shape. Okay.
And then I'll point them out when we look at the rocket itself, but we are using just standard 1515 rail buttons on the rocket. The part that we manufactured is going into a block of aluminum on the inside of the fuselage to help prevent tear out of the fiberglass. And I realized we forgot to put the cross section, what that was going to look like in there, but we can add that into any later submissions if you'd like, to kind of explain that a little bit better.
Can you tell us real quick where the placement of those buttons are going to be?
Yes, Eli, it'd probably just be easier to jump over to the see if it'll reach. So the buttons are, sorry, I'm just kind of looking. So we got the first one right there, right below the coupler joint. It's about 7 inches below it. And then we keep moving down to the bottom. We have the second rail button right there.
All right, Anita, are you okay with that? I mean, they're fairly close together, but it doesn't look like a very tall rocket.
Yeah, it doesn't. Would it be easy to see what was behind that top one to kind of describe what you guys are talking about?
Maybe, give me 1 second.
Okay.
And I didn't mean to disparage your rocket as far as not being very tall, but some of the rockets we've seen this year are ridiculously tall.
There might be a way, I don't know. Can you see that, Eli?
You can kind of see it if you maybe move the camera up a little bit and tilt it. Yeah, there you go.
So that's the block of aluminum right there that it's going into. It's got a machine radius that matches the ID of this rocket.
Okay. Does the bottom one have that too?
Yeah,
Or
it's
is it
the
in, like,
exact
the-
same setup. The actual the kind of concave radius that you can see on the bottom.
Okay.
is, the
That looks
ID of
good.
the other two.
Looks great, guys.
Yeah.
So we'll kind of talk about what this PA6 material is. We'll kind of go through it a little bit quicker because this is going to be our podium session here. Basically, what we're doing is we're taking carbon fiber, chopping it up and mixing it into a strand. You can kind of see that process there with the extruder. And then we are making a ribbon of material out of that. You can go to the next slide, Eli. Actually go one more time. So this is kind of a picture of what that material looks like. Those ribbons are filled with the carbon fiber composite to reinforce that material. The matrix is a PA6 nylon. And what we're doing here is we're welding the strips together to form sheets. And then the sheets are staggered so that the joints don't line up on each other. And then they are placed into a vacuum bag to be baked and cured into one full panel of material. And that's what that picture on the lower right-hand side of the screen is. It's the vacuum bag that we use to actually manufacture those panels. Those panels can then be used just like any kind of wood material. And so that's what we ended up using for any planar component in our rocket. So bulkheads, our fins, and then our centering rings as well. Go to the next one.
You want to go back or forward? Sorry.
Forward. Since we were kind of working with this novel material, then we did go ahead and go through some mechanical characterization tests. We went through the standard ASTM flexural testing with this material and the your good old doggone tensile test for this material. And so we were able to pull out some material properties and characterize that material so that we could use in our fin flutter analysis in our FEA. And if you go to the next slide, we can just look at some of the results from that material testing. The neat is just PA6 nylon together, and then the CFRN is the carbon fiber reinforced nylon. And you can just see how much stronger that material becomes, both for tensile and for flexural testing. And then I can turn it over. If you don't have any questions, I can turn it over to Eli and kind of.
Yeah, go back real quick. I just wanted to double check what I heard. So all of your, I guess, all of those interfaces, so your centering rings, your thrust ring, I guess the nose cone, all of that is made, all your flat surfaces, including your fins, are made out of that material. Is that correct?
Correct.
Okay. I guess we got to start talking about, again, I see your testing done here, where you've got, the mean neat, you're basically comparing the CF version versus non-CF version. But unfortunately, in my experience, I don't know really. I can see, obviously this carbon fiber is much stronger, but I guess from a comparative analysis, from my standpoint, I understand 1/4 inch thick plywood. I understand aluminum. I understand, G10 fiberglass that's, 3/8 inch thick or whatever. So while the numbers are neat, I don't see a compare and contrast between those materials. So I really can't tell you at this point that what you have or what you design are going to be strong enough comparatively to those. So a little bit of concern from there, but once I can see the materials, again, a lot of stresses on ejection, a lot of stresses on the thrust plate, a lot of stresses on the fins as well. So when we get to actually doing the top to bottom or bottom to top review of the rocket, we'll be able to see some of those real time, and we'll take some judgment calls as we can there. I'm certainly not questioning, oh my gosh, take it all apart and try it with different materials. While the material testing results right here it really doesn't help me or hurt me as far as is this safe or not. But once we get to it, and I can ask you guys to put some pressure on it, that kind of stuff, we'll take a look at it a little bit more. I guess the other part of the material testing, did you test at all as far as heat? How did the strength begin to fail while it was heated? I know the carbon fiber can usually withstand heating fairly well. It's the epoxy functions and the bonding, I guess, that fails from that standpoint. So, especially those centering rings that are going to be close to that motor mount, those get heated up. They take a little time. I just want to make sure nothing's gonna bust loose and fall apart. I don't want anything coming apart from the rocket as it's coming down. One large rocket under parachute's fine with all of its parts connected. When I start seeing motor cases and nose cones and other things separate with or without parachutes, that's when all the range safety folks get really concerned.
Right. No, definitely understand. And then just a couple quick answers to some of the questions you were asking earlier. After just doing a real quick search for kind of that qualitative comparison, basically this material is about the same strength as plywood, that 1/4 inch plywood that you were talking about, but for about half the weight. So just kind of for your information on that one.
That's great. I appreciate that. I mean, again, I hate to show my ignorance. I'm not really up to speed on megapascals and those kind of functions. But again, if we tie it back to that, and once I see it, and from that standpoint, I'll be able to care.
Right. And then there was no formal analysis on like the thermal effects of it at this time, just due to time constraints. We did identify that as a team as a possible future, actually, whole senior design project, going through a full structural and thermal analysis on the whole rocket. So we did identify that as kind of a weak point in air quotes for further investigation down the line.
Okay, so just to touch on our ejection testing real quick, I think we have a video here of it. We just hooked up a vacuum to our avionics space that we could simulate what a flight would be like for that, so that the flight computers could basically go under a flight without having to put the rocket in the air. And then we used 2 gram quad F G black powder charges. We bought the pre-packed containers off of oh man, I can't remember the name of the website, but the pre-pack containers that have about 2 grams of black powder. So we'll just play this video real quick.
There is a loud beeping in this video, so don't be shocked by that unless the volume's off.
Oh, sorry. So yeah, we had a successful ejection. We think that the reason they were so close in going off is just due to our vacuum not pulling a high enough vacuum difference between when the altimeters thought that the rocket was at altitude at apogee versus when they were at the altitude that we had set the main deployment at. And so yeah.
All right, Anita, you want to jump in on their ejection charge?
Hold on, I'm at an airport, so give me.
Okay, never mind. I can jump in. Can you guys go back real quick?
Sure.
Okay, so ejection charge testing has been one of Anita and my very, very detailed analysis and reviews, because what we notice quite often are some challenges and issues that we've noticed in testing. So I'm just going to ask a couple of quick questions. How many times did you guys do ejection charge testing?
So this was the one successful test. We did 3 tests or 4 tests before this, Peyton?
Yeah, that sounds about right. 3 tests, but with the
About 3, maybe 4 tests before this. This was the second day of testing. The tests previous to this were all failures, so this is the only successful test we were able to get. We didn't do any more successful tests, just lack of shear pin resources and black powder to do that with, and kind of timing. We were crunch time on our finals week and everything. So
okay, so let me throw out some challenges. Ejection charge testing is what you essentially did was probably the very first test, and that's not a bad test at all. However, you're not done. To successfully, truthfully test your ejection charge for that system, you need everything in the rocket. You need eBay, you need shock cords, you need parachutes. Basically, you need a ready to fly rocket. Obviously not a motor case or not a loaded rocket motor, but I would go ahead and put in the motor case, because you need to simulate the true weight of that rocket. You also need to simulate all of the congestion that's going to occur in those sections of the rocket. The shock cords themselves, you need to make sure that when the ejection charge fires, that when it fires, the parachute actually comes out instead of just jamming up inside of the rocket body itself. So, and having both sections eject at the same time is not a successful test. Typically, the vacuum test is great, and it does validate sort of the avionics for that, and that's fine. That's a good functional test without a problem. But quite often it might just be better to just hook up, like say the forward your drone section first, and let it fire off, and then maybe do the test again with your main and let it fire off as well. The other piece of it is when you're setting up your stand for the rocket, you don't want to anchor anything down. You don't want to just lay the rocket on the ground either. But what I'll typically recommend is have some type of vertical table, a small table or some form like that. Set the rocket up on it and let the two halves sort of push each other out of the way. You want to make sure, obviously, the shock cord is long enough that you're not going to create some type of situation where you're snapping cords and that kind of stuff. But again, the key piece not only is to make sure that the sections separate, but even more so important is to make sure the shock cords fully extend and you actually get a parachute that comes out. It obviously doesn't need to fully deploy, but if it gets stuck inside the body tube, that's not a successful ejection charge test at all. So you want to be real careful with that. And I would highly recommend you guys get back at it. You had mentioned purchasing ejection pre-canned ejection charge modules. If you need to bump that up, let's say for instance you get out the spaceport or you start testing with all the shot and you need to go to 2.5 or you need to go to 3. How are those pre-set up things going to work for you?
So our thought process with that was that we could wire 2 of the preset charges together, and if we needed to reduce the amount of black powder, and then we could pour some out of them and then set off 2 charges at the same time. In terms of that.
All right, and just to give you general feedback, most teams will purchase some quantifiable quantity, and this is where I want to be very safe and very careful here. You're doing a great thing by getting the 4F black powder, because a lot of teams are feeling like they need to do 3F and the Pyrodex and the smokeless stuff, and you can, but you have to work a lot harder with those to get the same results. 4F is definitely the best way to go, safest. The next step with that is, if you do purchase, usually comes in a 1 pound can. And you can, I know in Texas, you can purchase them at a lot of the hunting stores. They'll ask you who you are, what you're doing, and they'll take your name and some info down. But I also know that Animal Motor Works will be selling black powder at the launch site. Once you get that, I own several 1 pound cans. And the 1 pound cans always stay in a very safe, secure, locked place. The only time I ever work with the black powder when I'm building ejection charges, I have a very small little Tupperware. It's like one of those little tiny Tupperware containers that you would put your salad dressing if you were taking a salad to lunch or something. So, I mean, it might hold, I'll put maybe 10 to 12 grams of black powder in, which should be more than enough to cover all of my black powder charges for that day. And if something more had happened, a 1 pound can of 4F having a bad day will kill someone without a doubt. But having a 10 gram charge go off, it'll get you some burns and that kind of stuff, but it's not going to be the same. So again, be very, very careful with the 4F, but most of the teams have what's known as charge wells, charge canisters, and they'll put an E-match into their charge well, and then they will put in the appropriate amount of black powder, and then they will pack a type of cellulose-based insulation. We appropriately call it dog barf. You can get it at Home Depot, that kind of stuff. Not the fiberglass stuff, only the cellulose-based. The stuff that goes up in the attic of houses and such. And you stuff that into that charge well, and you pack it down almost as hard as you can. And then just tape over the top of it with some type of good strong tape, like Gorilla Tape or something similar. And that'll create that good ejection charge that you want, generating the gases and getting the pressure differentials so that the sections fly as they're supposed to. So just general thoughts. If you have more questions, don't hesitate to ask me or Anita, but I would suggest you get back to testing your ejection charges.
Okay. I guess just some comments on that. We had some logistical issues basically with our school in acquiring large amounts of black powder. So this was our only option to get quad FG black powder, was using these pre-packed charges. So we originally had designed to use charge wells with black powder that we would have bought in like a 1 pound container, but we were unable to do that.
So when you run into problems with is it like environmental health and safety or your risk management group?
Yeah, it's our environmental health and safety department.
Okay, so ESTRA has a lot of experience working with environmental health and safety groups and risk management. In fact, we have what I would consider one of our national experts on the team, happens to be the director of environmental health and safety at Iowa State University. He's also a level 3 Rocketeer and the advisor for their rocketry team. He is teaching a class on Monday at Spaceport America, and he's bringing in, I think there are 14 or 15 different school, either directors, associate directors of environmental health and safety, to train them on true dangers, true risk, true mitigation strategies for this. So when you start running into environmental health and safety folks that are, because if they're fighting you on 4F, which is relatively low risk compared to some of the stuff that you may want to do in the future. Say for instance, typical traditional pathways for development of a high power rocketry team. You're doing commercial motors now, but if the team continues to progress and does well, you guys are eventually going to want to start looking at potentially making an SRAD motor. And all of a sudden you start talking about ammonium perchlorate and all sorts of other fun chemicals that go into those type of motor mixing situations. And that's when your environmental health and safety folks really go off the deep end. And so having a resource like this, and let me even step back even one step. Thank you for engaging your environmental health and safety folks. You need to keep them on your team. I mean, when you're doing critical design reviews, when you're doing anything, always include them on the discussions. Send them design documents. Make sure that they are in front of the problems, potential problems that they might have. If you guys have an incident and your environmental health and safety folks were on top of it, they were aware of everything that's going on, they will be your biggest protector. If you sneak something in and somebody gets hurt, they will be the one that shuts the team down. So, again, soapbox type scenario, but there are too many of the environmental health and safety folks that don't have enough experience and research, I guess, to understand what the true risks are and what an appropriate mitigation strategy is. And that's where ESRA can really help out, and we can link your environmental health and safety person with our environmental health and safety person, and get that communication and education going. Will make your life a lot easier.
Yeah, that would be great to do when we get down there and get a chance to talk with him, because that was the source of about 85% of our issues this semester. So
just to let you know, his name is Bill Dieslin. And if you talk to the Iowa State rocketry team or you run into them, he's their lead advisor. So and he will definitely be wearing an ESRA blue shirt. And if you can't find him, find me and I will hook you guys up with him.
awesome. Thank you. Do you have anything else you wanted to add, Peyton?
The only thing that I was going to add was that we throughout, we did run into these setbacks during this project, and we did implement some of those safety considerations that you were talking about earlier. We have little micro vials that we found on Amazon, so that we're going to check out the black powder that we need for competition, so that we're not bringing a full pound down. And then also, as part of this project, we did do about 5 or 6 job safety analysis through or with EHS on campus. So hopefully that we're the last team on campus to kind of run into these particular setbacks, and hopefully future teams will be more set up for more success in the future.
Absolutely, you develop the confidence in the partnership, and it'll definitely make things much easier. And again, when you're working with them and they're partnering with them, they will protect you when something potentially bad does happen.
Definitely. All right. So the next kind of the next bullet point for the feedback that we got was just some clarification on what we were using, what event meant to us as we were using it in the report. Our initial interpretation was a misinterpretation on our part. We said that we had 8 events in total for ejection charges. We were interpreting that as 4 charges with 2 signals per charge to give us 8 events. And then the more correct interpretation would have been that we have 2 computers that are giving 2 signals each. So we have 4 total events, 4 separate charges in the rocket. I think, Anita, does that kind of clarify?
It does. Thank you.
Okay. And then there was just a question on what we were running for the batteries, and we kind of look at them in a little bit later, but our flight computers are running off of a 9-volt battery for the RRC3. And then the Easy Mini is running off of its proprietary 400 milliamp hour battery that it's designed for. We'll go over the switches themselves kind of as we get a little bit more, as we start looking at the real life things, but we're just using some rotary switches, and we'll point those out when we get to the real rocket. So we did, for whatever reason, when we submitted our open rocket file, some of the items were not correctly specified with the masses. And if you'd like, we can take a quick field trip over to the open rocket file and take a look at that if you'd like.
We don't have to. I just wanted you guys to really understand and make sure you looked at it, because like I noted, your coupler was in the simulation saying 0, and I definitely know that's not true. And I just wanted you guys to, look at that. And as long as you guys did update that, it's really for you guys on how accurate your simulation is to, the actual material. So as long as you guys went back and looked at it, I don't necessarily need to look at it, but we can if you want.
I think we could probably leave that for now. We did go back and
Okay.
we did go through and make sure all the masses that were in the simulation matched the actual real world masses, now that we had physical components to actually compare those two. So that's pretty accurate. And then our plan is once we have our launch ready configuration with all the paint, stickers, all the bells and whistles on it, as if we were ready to fly it, we would do one more double check between the simulation and the real world rocket, just to make sure that we're putting good things into the simulation, because we're, we kind of follow the adage of garbage in, garbage out here. So yeah, I guess now we can kind of, unless you had any questions on those items, we can kind of go over to the mobile cam and kind of look at something, whatever you'd like to look at.
Usually we start from the bottom and make our way up through the top. So let's go ahead and get the fin can up on a table or wherever is comfortable for you guys. And we'll look at motor retention and the thrust plate and the fin connection points.
Okay, let me just kind of move some things around and get set up for that real quick. All right, so we got this is kind of our boost section here. We can start from the very back if you'd like. First things up. Yep. Go ahead.
All right, let's go ahead and look at the I guess retaining ring and thrust.
Okay, so we did purchase this Aeropack retaining ring. It is epoxied in place, and before competition, it will get another layer of epoxy just to really secure that in. We have our motor case will obviously go in there, and then the ring will secure it in place.
Okay, real quick question. Do you see all the little holes on the side?
Yep, all these little holes for the screws.
Exactly. Are you
Yep.
guys planning on utilizing those?
We were not planning on utilizing them just because of the material type.
Okay. Do you understand the amount of heat that is generated at that particular point of the motor? That is
Yeah.
the hottest point on the motor, and you are relying on epoxy to hold that in place. Wouldn't you think that a mechanical function would be a
You kind of came in a little broken there, but I'm guessing the question was the merits of the mechanical fastening versus the chemical fastening. Is that what you're kind of getting at?
That's it. Absolutely. Again, that is the hottest point of the motor case. and that heat transfers just wonderfully through that metal case, that metal to metal section. And if you're relying on epoxy, that epoxy is going to fail when it gets hot.
Right. Yep, no, you're definitely right on that. We did kind of take not saying that it's going to solve every problem, but we did use high temperature epoxy. Back there, we're using the G5000 rock epoxy on this particular component, and it will get another coat, and we might even explore some kind of like reflective heat protection by lining it with some like aluminum foil or something, just kind of reflect some of that heat away.
Yeah, I wouldn't be messing too much around that. Would it be too much? I mean, what is the challenge with just putting a few self-tapping screws into some of those holes?
It wouldn't be too much of a challenge, and we can definitely put at least 3 or 4 in there just to kind of give it a little bit of backup.
So just for future reference, there's a reason that they design them with those. Again, I have seen too many situations over the years where they have a really nice motor retainer, such as you guys have, and at the end, the ejection charge fires, and now I've got a 6 or 7 pound large 98 millimeter motor case falling from the sky without a parachute, and it's not a fun thing. In fact, I think the scariest thing falling from a rocket that came within several feet, I mean, probably within 5 feet of a person, was a motor case many years ago. So we're very particularly worried about those kind of functions. Those really do scare us a lot. But I'm just saying, when you go forward with your range safety inspection, if you don't have at least a few screws in those holes, they'll probably red flag you for that one.
Okay, we'll add some in there as well.
All right, let's talk a little bit about the fin mounts, or excuse me, your thrust plate itself. So the thrust plate that is in there right now, your motor retention ring, the motor retention ring itself, is there a gap in between the motor tube and the lip of that retainer?
Are you talking about like kind of like here?
Nope, on the inside of the tube. You see the red motor tube?
Yep.
Okay, so that motor, that adapter should slide all the way in, and there should be sort of a stopping point where the tube will not go any farther in on that. Are those two, I guess, the face of the motor tube and your adapter, your motor retention, are those touching the way they're supposed to?
If I'm understanding what you're saying, yes, they are. Everything, the thrust plate is flush mounted to this, to the actual threaded component, which is centering the motor tube itself. And we do have the motor casing here, and everything slides in and fits in together.
Okay, it just looks like there's a gap. And I'll take your word for it. Don't worry too much about that. But the key piece is that is a motor retention system. When your motor case goes in there, though, it's going to be pushing on, hopefully on probably the outer, or that inner black ring, and that ring should be pushing directly on the motor tube. So that transfers a majority of the motor thrust, because that's what keeps the motor case from sliding up through the rocket.
Right. Yeah.
Okay.
The motor, this motor adapter has a lip right here that the motor case seats against, and then it might not be coming through on camera, but there is a direct transition from the retainer into the motor tube. This black is just the thrust plate itself showing through.
Very good. Okay, that's the key piece. It's tough to tell over video camera, but that is a crucial piece, because once that's in place, then all of the force from that motor gets truly transferred into the centering rings, and that's what we're hoping for. there's any other type of gap between those two, then we have some other challenges going on. So the rear centering ring is one of the most crucial ones that we talk about. Your thrust plate is another term that we call it, the rear centering ring. And so looking at it, I'm not seeing any fillets. I'm seeing some epoxy around it, but I'm not seeing any fillets per se.
So there are no fillets on this side that we can see, but if we were to look at, if we kind of put on our X-ray goggles, we have a centering ring here at the edge of the fins. And then we have a centering ring here at the back edge of the fins as well. And there are internal fillets all the way around that whole kind of tub section in there on the interior side of things. And then we have external fillets between the fuselage and the fins themselves. So there's no fillet yet here, but there are 8 internal fillets on each kind of quarter of this section.
Okay, so when you were, I noticed the gaps. So you basically attach the fins to the motor tube, and then the centering rings as well, and you just slid those into the body tube. Is that correct?
Correct. That's what these gaps are here.
Yep.
They're just clearance for
Yep.
seating the fin up against the.
So when you were doing that, did you take pictures of it?
We did not. That was something that we realized after the fact that we probably should have taken some more photos just during our assembly period in general.
Okay. All right. Then I'm going to go ahead and move on at that point. But it would be nice if you could, thicken up some epoxy. Make it thick by adding some chunked up CF or fiberglass or something. Just turn it into a paste, or you can buy air epoxy or something similar, and just make some fillets around that the inside section of that, so that we can see that the interface between the thrust ring and the body tube on the inside has a good strong connection with some type of epoxy.
Sounds good. And just so I know that I'm understanding you, you're talking about putting fillets basically where my finger is.
Nope, on the where they turn your finger around opposite direction, upside down. Nope. Now the body tube, so the outer body tube. Okay, now slide back towards me, and just where the body tube on the inside touches that centering ring, right
Okay.
there.
Yep.
That's
Sounds
where you want your fillets. That's where the interface, that's where the energy of that motor gets transferred to the body of the tube.
Gotcha. Yep. We'll definitely do that.
Okay. Moving on, your fins look good. Those look like some solid fins. They're pretty beefy. What is the thickness of those bad boys?
These are 1/4 inch thickness.
Holy cow. All right, very good. It doesn't look like they're fairly flat. You didn't make them aerodynamic at all. And that's okay, but when you get there, you're going to see some that are ridiculously sharp. I mean, like walk by, accidentally cut your arm off kind of sharp. And then you'll see some that are like this as well. You just want to be careful with that, because when you're designing and developing your simulations, your coefficient of drag, squared off fins can actually generate a significant amount of drag overall. But it'd probably be similar to having a super shiny coated paint job versus just having regular body tube kind of stuff. So anyway, no big deal. I'm not worried about those fins flapping at all. Those things look beefy. Fillets look pretty good too. I'm assuming you guys have not done a tip to tip type of layup between the fins.
Correct. No tip to tip, no kind of layup at all.
Okay. That all looks generally really good to me. I don't see any major issues there. With the motor case, let's flip it around. The buttons, I think we're in good shape there. Anita, again, don't hesitate to interrupt me when you have questions. So let's look inside, and so I didn't see where the shock cords are going to get anchored to it.
Okay, so they're not in here yet. They're actually going to be on this eye bolt
Good.
here on our motor
Okay.
kits.
Excellent, excellent. Okay. You just, the key piece in that special little area right there is just make sure that eye bolt is in there snugly. You do not want the flipping of a parachute round and round and round to put torsion on it and unscrew that. We've seen that happen before too. Quite exciting, not fun. So you want to make sure that that is in there and it's not going anywhere, because that is a fully welded, beautiful eye bolt. That's what we like to see.
Yep, and just to kind of address that, when it's competition ready, this is going to have Loctite on it. All our threaded interfaces are going to have Loctite, and then there is a swivel link that's in between this component and the parachute, so that hopefully will avoid some of that twisting motion that you were talking about.
Yep, that sounds good, guys. I like that. As long as the motor stays inside that fin can and with the retention, all that kind of stuff, that fin can should be safe and snug against the rest of the rocket. So I don't want to see that piece coming out. So that's looking good. Let's see. The coupler looks to be in fairly good shape. I don't see any issues there. Do you guys have any problems bonding that together?
No, it actually bonded together pretty well.
Okay. Are you guys planning on doing shear pins on the lower half?
Yes, each joint is going to have 3 shear pins. You can actually see that we still have to get the shear pins out from our ejection testing.
Yep.
But we'll have 3 shear pins in there.
Okay, that's great. Are you guys doing your drogue should be coming out the bottom? Is that correct?
Eli, you want to hop in on that?
Yeah, so our drogue is going to be connected to the motor section, and then our main's going to be on the top connected to
Perfect.
the payload.
That's I just wanted to double check. That is the and again, you can get into religious battles. It's just you ask one Rocketeer and he's going to say, "Oh," and another guy's going to say, "No, it doesn't matter." And all the experts I've ever dealt with that I had true respect for follow that mantra of drogue in the main. So very good. Okay.
Is there actually space for that motor casing plus the drogue? Just kind of, have you guys actually loaded it with everything in it? Besides, I mean, the full loader motor, of course, but like casing and drogue, does everything actually fit in there?
Yeah, so I'm going to set the camera down real quick and I'll set this up. So on this side of things, we have about 6 inches of clearance, which doesn't seem like a lot on this side, but when we go to this component, if I can frame it up right, we have another 18 inches of clearance, or not 18, 24. Yeah, 18 inches of clearance on this side. So we have about 18 total inches, not counting the overlap between the couplers for fitment of all the internal components, if that makes sense.
It does.
So that is a lot of space for 2 grams of black powder. So interesting. And usually in a 6-inch diameter rocket with, you're talking 18 inches. That is a lot of cubic space for 2 grams.
Yep.
I usually do 2.5 in my 4-inch rockets. So I would be very interested to see when you load all the gear up and everything, to make sure that here's another little test. When you fire off your tests, are you firing off both charges at the same time? So you're essentially getting 4 grams, or are you doing just a single 2-gram charge?
Just a single 2-gram charge.
Wow. Okay. All right. Well, again, that's continue testing it with that single 2-gram. What should happen if you're designing your ejection charges properly, you don't want both of those charges firing at the same time. And usually the computers will be slightly off in their evaluation of apogee or non-apogee. And even the same thing with the main altitude. One may think it's at 1,522 feet, and the other one was like, 1,500 feet. But it never hurts to add. I know on the RRC3 as well as I think the Telemini, you can add a second to apogee plus 1 second. And what that does is, if the first one separates the rocket, but it doesn't push everything out. It gives a little bit of time for everything to sort of clear up and maybe it's in a bad situation or it was going way too fast or who knows what. When that second charge fires, it has a much better opportunity to clear everything out than both of them going at the same time. We've also seen situations where both of them went at the same time, fired it off so hard that it just sheared off bolts, it sheared off shock cords, it shredded parachutes, all sorts of other problems. So it's good to try to segregate the ejection charges to a certain point.
Yeah, I think we do have a delay between the two. I can't remember the exact time. Peyton might be able to tell you, but
Josh is on with us. Josh is our avionics guy, and he can answer that for sure.
Sorry, what was the question?
what's our
What's their
delay between the two computers?
I believe it's a few seconds at apogee, like 3 or 5 seconds. And then for main, it's actually set by feet, which I think is like 500 feet. I think is what it's set at now.
All right, you mean 1,500 feet?
Delayed 500 feet. So the first one will go off at 15, and then the other one would go off
I see.
significantly lower.
Okay. I would probably shorten up those a little bit, 1 to 2 seconds for the apogee, and then maybe 100 to 250 feet at the most on the mains.
All right, I'll have that done.
Also, what size are those shear pins?
Peyton, they're number 4s, right?
Number 4s, yep.
Okay.
They're a nylon plastic.
Yeah.
All right. Anything else on the fin cam? You want to move up to, I guess, let's talk a little bit more about parachute harnesses, talk about the shock cords, connection points, those type of things as well. So we saw the one on the fin cam, that looks great to the motor case. Let's look at the other side of it. So drug chute itself and the shock cords. What are you guys using for your shock cords and what are the lengths?
I have that pulled up, Peyton.
Trying to give you like an overview of what we got. Eli, if you want to go through it.
Maybe I have that pulled up. Okay, here we go. Okay, for the drug parachute, so the shock cord that's connected between the parachute and the motor section is a 950-pound shock cord. It is 20 feet long, and then the shock cord connected to the avionics bay and the rest of the rocket is a 1,200-pound shock cord, and it's 25 feet long.
Right. We need to know, and those numbers sound really low to me. What are we talking about? Are you talking about braided Kevlar? Are you talking about nylon?
Yeah, braided Kevlar.
Okay. So if you think about worst case scenarios, let's say, for instance, something malfunction and your rocket's launching, it's rolling up through, maximum aerodynamic pressure and all the other neat things. And something in the avionics tells it, I just had a massive pressure increase. And it now thinks that it's at apogee, even though it's going 650 miles an hour. So I'm going to fire off my ejection charges. And this happens. This happens a lot, actually. One of the scenarios that happens is your parachutes, potentially your drogue, potentially your main, will open while you're still going blazing fast. Now, tell me real quick, how do you think those 900-pound shock cords are going to stand up to something like that?
Probably not amazingly if we're going at our max speed. I believe based on our calculations, we had factors of safety greater than 5 for all of our shock cords, which was based on the acceleration of the sections after the black powder charges go off, plus
right. In a nominal launch, those things will work fine.
Yeah.
What I'm worried about is the non-nominal launches. So what we typically see from rockets this size, what's the overall weight of the rocket itself?
The rocket, fully loaded, including the motor with propellant, is sitting at about 55 pounds.
All right, so I'm going to tell you real quick, and this is my take, and they'll probably tell you the same thing. I would say the braided Kevlar that you have there would be absolutely fine for a 15 to 20 pound rocket. For a 50 plus pound rocket, you need to probably go up to significantly larger. I'd say half-inch probably would be appropriate, and that's closer to the 3,000 pound range.
Okay.
So I hate to do that to you, but lengthwise, I think you're in good shape. And let me explain to you what happens with Kevlar. Nylon has its benefits. I mean, people use nylon to climb mountains and such. Nylon is great in the fact that it doesn't really get worn out terribly quickly. It has a decent lifespan on it, and it also has a flex function. So nylon will actually stretch to a certain extent during high stress periods, and that's great. Nylon is really bad with heat. Ejection charges in nylon, not good friends. And that's where Kevlar steps in. Braided Kevlar is super strong and really could care less about flames. I've had them, that literally had black char all over them that they're still, strong as could be. The problem with Kevlar, especially on short Kevlar, if you had an 8, maybe 10-foot section of Kevlar, the ejection charge fires, and there's still a significant amount of inertia flying when those things max out. And when they snap, Kevlar does not flex at all. You've seen videos where you have 2 trucks having a pull off where they have, like a 100-foot section of rope between their bumpers, and the 2 trucks take off in opposite directions, and one bumper will hold, the other bumper won't, whatever. So, but this is a scenario where that Kevlar will not break. Something else in the rocket will break. And the longer you have, typically we ask for at least a minimum of in between sections. When I say section, I'm saying the nose cone parachute to the coupler or to the rocket eBay section. 20, a minimum of 3 times the length of the body of the rocket.
Yep.
And it sounds like you guys are good with that number. 20 foot's perfect. I would just bump it up to the half-inch Kevlar if you're going to do that.
Okay.
Next thing I want to ask is, how do you connect? How are you connecting those to those connection points? Are you going to knot them? Or are you going to buy the ones that have pre-stitched slots in them? I mean, what's the idea?
Peyton can show you those. They're Kevlar soft links. They're rated at about 950 pounds. And so if we want more strength than that, you just add 2 or 3 or whatever to make it work. I think Peyton's got it pulled up on his webcam.
Yeah, so that's that soft link that we're talking about. I think our plan is any kind of metallic component is going to have one of these between whatever their 2 items that are being connected are.
Okay. I'm sorry. I've heard of these. I'm not sure how they work though. So if you had the end of the long section.
So the ends are going to kind of
Okay. See
look
that?
like that. And then based on how we wrap this, we can actually go around a couple times to increase the strength of the, I'm trying to think of the right word, basically increase the strength of the actual connection by multiplying the number of strands that are on the connection.
Okay.
So like this would be twice as strong if it were.
I copy that. So at the end of that though, you're going to connect that to like a D-link, I would guess.
Yep. So all 3 of these or 2 or whatever would go to our swivel link, a 1,500 pound swivel link. They're all connected there, and then they would go on to wherever they're going.
How are those connected on though? I guess that's what I'm asking.
It's the same type of connection. You just have to knot it up again on each side. So maybe I can.
Oh, so each end has sort of a loop on it?
Correct.
Hmm. Okay. I guess what I'm sort of poking at is if you guys are generating knots, just ensure whatever knots you do, don't have any option or possibility of coming unraveled. And in my scenario, my experience, I always leave a significant amount of the shock cord on the opposite eye, the loose end of the knot, and then tape that to the rocket so that it has really no chance of sneaking out. So again, we love to see the stitched loops. Those seem to be extremely strong. But if you are going to tie a knot, just make sure that it is some type of knot that will not loosen or come loose. And those will be certainly evaluated during your range safety inspection.
Copy that.
So when we're talking about, those links, anything that's 900 pounds, I would request that you try to get those up to closer around 3,000. So those little loops there are, same size as the small shock cord. You'd probably need to replace those as well.
Yeah, with those connections, you can just use 2 for a connection. That would theoretically double your strength, basically. So that was our plan there.
And I think we'll be okay with that.
And also to tag onto that, besides the motor, besides this point, all other points have 2 or more of these connections going into one mode. So we do have a little bit of redundancy as well.
That's great. That looks wonderful. All right. So that is again the fin can. Oh, I'm sorry. That's not the fin can. That's actually, that would be the bottom of the nose cone, correct?
Correct. This will sit in the nose cone, but this is just the payload that's exterior at the moment. I think you're muted.
Sorry. If you could, since we're at the nose cone already, let's grab the body of the nose cone and let's go ahead and insert that in there. And let's talk about how we anchor that into the nose cone.
Real quick, just because this might be a little.
While you're doing that, the white part at the top where it looks like the screw holes go into, what
Mhm.
material is that?
It's a plastic, just I don't know, Peyton might know exactly what it is, but it's just a standard plastic. It's kind of weighted to improve our center of gravity, center of mass, or center of thrust balance.
Okay,
You're talking about this white piece, correct?
Yeah.
Yeah, that's high density polyethylene.
okay, and that is, I guess, the only place that it's, I guess, bolted in to the nose cone.
Yeah, there are 4 screws that go into that high density polyethylene plate.
Oh. Of course, it's really dark. It's in there now, but
So you got, that's your payload. So you're talking 8.8 pounds, plus the weight of the nose cone itself, which may potentially 3-4 more pounds. So you're talking a 10 or 11 pound object.
correct.
And so you've got 4 fasteners of some form going into a plastic retention item. And again, in nominal flight, you should not have any problems at all. But I'm worried about the non-nominal flights. What are the chances of something, going extreme onto that scenario? So let me see. I was sorry. Was that one of the nuts that you had? I didn't.
Yeah.
In front of the camera real quick.
So this is
Okay, so those are not small.
Oh, these are quarter inch long stainless steel, right, Eli?
Yeah, I
Okay.
think they're zinc plated, not stainless steel, but yeah.
Any concerns with putting another, you said there's 4 of them now, correct?
Yeah.
Correct.
Okay. How thick is that plastic plate?
2 inches thick.
Okay. You know, if you put another 2 in, if you could somewhere, that would hopefully alleviate any concerns, because the concerns are obviously that if we do have an off nominal situation and that parachute hits and everything gets, you know, the worst type scenario you can imagine, what is going to fail first? Is it, you know, that plastic piece? We're not really excited about plastic. That's always a weak point. Luckily, there's no heat in that area, so we don't have to worry about that. So it's 2 inches thick. The screws themselves look to be fairly substantial. You have 4 of them, maybe 6 of them. I would say that I would be comfortable ensuring that doesn't come out. But the other concern is you have a significant amount of weight in that nose cone. So you add the weight plus the shock of, you know, whatever the event is. I would definitely feel more comfortable if there were another 2 inside of there.
Sure, that'd be easy to do.
Yep.
So
From when you guys had it out, wasn't there like a top plastic piece and a bottom? So like it essentially top and bottom. So you would have 8 screws total in a sense holding that in. That's how I pictured it when you guys had it out.
So there is that bottom piece of plastic. We could potentially put another 4 screws in there, but at the moment there's not any screws in there.
I would recommend honestly putting 4 screws in there so you have it actually sandwiched in that section. So you have that upper taking some of the load and the bottom it's kind of distributed throughout the airframe, not just those 4 points. So
I completely agree with Anita.
yeah, I would recommend that.
4 and 4 is better.
That's reasonable. We can do that.
Nice, guys. All right, we're moving along pretty well here. Now it's fun time. Let's go ahead and take a look at your eBay, your avionics.
Okay, I'm gonna set this down again real quick and just kind of move some things around.
Now, you guys have not had any test flights, is that correct?
that's correct.
Okay.
Not
In
this
the
rocket, no.
future, in the future, we have not made it a requirement because of so many international teams. Do you guys have the ability to launch somewhere, a rocket like this?
Yes, it's a bit of travel for us, but yes. The main reason we didn't have a test flight was financially, we didn't have enough money in our budget to buy another motor.
So I understand that completely as well. However, this is an expensive event, and so you need to make sure that you market the team properly so that you bring home lots of trophies and prizes so you can show your department and your advisor, Dr. Ash, and he can go pitch for more money from the department. But even more important than that, find those sponsors. You will be shocked when you show up. This is y'all's first cup, is that correct?
Technically, it's our second, but the first team to attend this cup was back in 2017, and they were more of a recreational team.
Gotcha.
That way, so our whole goal with this project is to basically build a platform that future teams can iterate off of and do the cool stuff. We're just building the base model.
No questions at all. This is going to be an enlightening opportunity for you guys to see how some of the other teams operate. You'll see teams that literally show up with a rocket that is decorated, literally doesn't have any free space on it because there's so many sponsors. It'll look like a NASCAR rocket. You know, every company they can find has got a sticker on it. And even if the sponsors only giving them, you know, $50 or $500 or $5,000, whatever the case might be, or donating material. Um,
Muted again.
So definitely make sure that you're collecting video. You should have somebody that's sort of responsible for walking around, taking photos, taking video of the team working, watching some good video or capturing some good video of the launch, because that is how you market to these sponsors. You need to get your websites looking good, and you'll have teams showing up that have budgets over $200,000. It takes a while to get there. It doesn't happen overnight, but in the end, trying to get a team to New Mexico every year is a challenge in and of itself. But you should be able to budget for at least 2 or 3 motors for testing throughout. So next year's rocket, there should be, I would say 2 to 3 test flights. We've had 5 different test flights just in the teams that Anita and I have been reviewing over the last 2 weeks. 2 of them are going off tomorrow. And they are fully prepared that if their rocket crash lands and they have a complete disaster and have to start over again, they already have plans in place to rebuild their rocket within a month. So that's how these teams sort of plan their universe. The teams that win, last year's winner, Sydney University from Australia, they had 4 test launches. They were within, I think, 12 feet of their target. All of their test launches were successful, but they were just refining their coefficient of drag on their rocket. And the team was just meticulously professional. Top to bottom, everything was checklisted, safety checked. Everybody had their jobs, knew what their jobs were. And so again, take notes, watch some of these other teams, learn from them. You'll see some bad habits, you'll see some good habits, and just be better prepared next year. And those test flights are going to be important. We don't require them, but we're getting real close to requiring them. So again, just giving you a heads up for that. All right, so let's start in the eBay real quick.
Josh, you want to take over?
Yeah, I can.
All right, tell me where you want me to go, and I'll just kind of drive there.
So we have 2 computers, the Easy Mini and the RRC3. One has, as mentioned before, a 9-volt battery for the RRC3 on the bottom, and then the Easy Mini is connected to a battery that is sold for them. That's 900 milliamp hours. And at the bottom, we have a featherweight GPS connected to a 400 amp hour battery. And all the electronics are held on by screws that go completely through, and then have the locking nuts on the end. And then the batteries at the moment just have tape through them, but they'll also have some zip ties to make sure that they don't move in flight.
Is the sled 3D printed?
Yes.
What's the material?
Peyton.
So the sled was actually one of our sponsored components. We were going to mention our sponsors at the end of this, but B9 Creations here in Rapid City was able to print this out for us. And this is actually a electrostatically safe, or an ESD safe nylon material.
Very nice. It looks pretty beefy too. That's the important piece from all that. I like to hear zip ties, particularly with your batteries. Be very careful with that Easy Mini. I mean, it doesn't look like much, but it's a pretty powerful avionics package. Do not go out and buy a third-party battery for that, because that battery is specifically made for them. Ask me how I know. It was not good. So if you don't have a second, third, and potentially fourth battery, I would get with them immediately and buy some more. Luckily, we have Animal Motor Works who will be selling those batteries. But again, do not go out to Amazon and look at the whatever the nomenclature is for it and buy a bunch of those off of some RC control place. I did that and it didn't end well. They are specifically made and the wiring is different and there's a control chip and lots of other stuff going on there. So very good from that standpoint. Let me look real quick at the electrical connectors to that front end. So I've seen a couple of examples where, so you've got bolts that are going through and you've got your charge lines going to those bolts, and then they come out on the other side and those go to your E-matches. Interesting. Okay. So the charges, so what we'll typically see on that, so scroll down real quick. I just want to see the top face of one of those areas where you have the eye bolts. There you go. So usually what we'll see there will be the charge wells. And the charge wells will be anchored like about where the tape is. So you have a primary and a secondary charge well. I guess what y'all are doing here is y'all are just going to sort of toss the ejection charge and connect it to the wires, obviously. And then the charge canister is just going to sort of dangle loosely in the bottom half of the rocket.
Yeah, that's correct. The duct tape you see is covering the hole that was going to be used for the original design with charge wells.
Okay. So why did y'all decide to not use charge wells?
We couldn't get the black powder separately outside of the pre-packed containers.
Wow.
And then, yeah, it just didn't work out. So we switched to this design.
I gotcha. Okay. Well, I mean, the tape solution is great. Another solution you guys can try, and I do this all the time. If you peel off one side of that tape and then just put some epoxy in it and flatten it out a little bit, that hole is almost as strong as the original fiber, or the original material. So you can fill that hole, but the tape's fine. I mean, just throwing that out there. We used to do that with fillets, not fillets, but trying to fill centering rings inside the rocket. We drill a hole so that we could put epoxy in it, slurry the epoxy around inside the fin can, and then put in just a little bit of extra epoxy and then put tape over the hole and allow that thing to reseal itself. So opportunities there. I'm just, the only thing is I'm worried about the ejection charge sort of flopping around in there with the material, because when the rocket takes off, a couple of things happen. There are a lot of G forces in play. The parachute, that is both in the drogue and in nose cone, they'll get compressed down. So really it'll be your drogue ejection charge will potentially get pressed downwards. And so the wires look fairly strong. The bolts holding them look fairly strong. The charge probably isn't very heavy, I wouldn't think. But I'd feel a lot more comfortable if the charge was, and we're talking 2 charges, correct?
Yeah, in each.
Okay, 2 on each. Okay. Is there any way that you guys can anchor those charges to that? So like where the tape is, if you could just use that tape or another piece of tape.
We could definitely work something out where we're securing it a little bit better.
Right against that wall. Would that work? Just don't like seeing wires flop around inside there. Need any recommendations? Any other things that?
I would recommend taping as well. Maybe just stick it right over where you guys did those holes. My question though, what is that plate made out of? Is it the same material as the sled essentially?
This plate,
Yeah.
the same material as our fins. That's the same material
Okay.
that's our centering ring. So this is also that carbon fiber reinforced nylon.
Okay.
How does that, and I'm assuming the other side will be, I guess, similar functionality there. Again, we don't see many of them set up this way. Usually it's, you'll have the wires going through connecting to some some type of connector, and then the drone, the charge wells and the wires connecting to those. And this would function. I can't imagine any other situation where it might come loose. I guess the key piece I would also look at is inside the eBay itself. You don't have a lot of excess wiring, which is great, but you want to make sure that any wire that's in there is dressed properly. A lot of vibration occurring. So do you see where the two little green wires right now in that view are connecting to your altimeter? The problems we always run into is the vibrations and how those things will come loose. And it'll be amazing that an extra 3-inch loop could be just enough force to pull that out during a launch. So the test during your preparation for the eBay and avionics side is to obviously fresh connections. You want to pull that wire out. You probably want to snip it off, put a nice, clean, fresh connector on it, slide it in there. Make sure that, and then crimp it down as best you can and give it a good tug test. Connect it to the end where you want to normally connect it, and then secure that wiring so even there's no excess flopping around anywhere. It should be, even if you have to do zip ties or a little bit of hot glue to secure it, just keep it from flopping around and make sure there isn't any loops or excess such at all. So same thing for battery wires. You want to make sure all of those are well connected and aren't going to go anywhere. Trying to think of anything else. The 9-volt battery. Every single flight that you put this rocket on is a fresh out of the package 9-volt battery. I don't care if that thing's already showing 9.2 volts or whatever the case might be. If you didn't just take it out of the package, you're doing yourself a disservice. We used to highly recommend Duracell because they were welded connectors. Well, guess what? They're not welded anymore, so they're just as crappy as all the other ones.
Definitely agree. Well, that's definitely in our plan. And then also most of the wiring that you see here is our preliminary kind of tests.
Yep.
And then before competition, we're going to make a full-blown wiring harness for it, so everything's nice and secure, like you were talking about.
All right, so just be careful when you're saying that, because this is supposed to be sort of a final rocket safety review.
Gotcha.
All right, so that's okay. I mean, at least you guys have a rocket put together. We've run into teams that we're still trying to get parts. Let's see. Let's talk a little bit about the GPS. So Big Red B, 900 megahertz. Is that correct?
Yeah, it's the 900 megahertz band.
Okay. And you've tested it already in this configuration and with this eBay. So I'm taking it the fancy non-conductive material that you have is not blocking RF or anything like that.
Correct. We've done some tests with it. We
Okay.
just got a couple more planned. Basically, we're probably going to go play a game of hide and seek with it.
Excellent. That's always fun. And I see you got a nice SMA connector on it. That's really good. Those things are so much stronger than some of the stuff that I've seen. Again, you want to secure the wire. Make sure that battery is nicely charged up. You need to have multiple backup batteries as necessary. And then your receiving station. Have you guys already submitted your RF frequency form to DaVinci, to the RF guys?
Correct. And I just got an email back today saying we're all status complete on that.
Outstanding. Yeah, there's still 5 or 6 teams I got to go yell at that haven't even turned in a form yet. That's good. That's very good. Again, I practice on the GPS. When it's in the air, it's going to be great. If you've got it generally functioning in the air, it'll be fine. 900 megahertz, I always recommend to have specific frequencies, but there's going to be a lot of other 900 megahertz systems out there. Hopefully none that step on top of yours or potentially causing interference with yours. But once they're in the air, you typically won't have any real interference once they reestablish connection after boost. but as they get closer and closer to the ground, especially if they're a long distance away, you will lose your connection to them. So get really good at saying this was the last received packet, and being able to quickly throw that into a mapping system, whether it's a laptop, cell phone, whatever the case. Cell phone connections out there, not good. Not good at all, actually. They are building a brand new cell tower that is going to have T-Mobile, Verizon, AT&T, and one other. And they were supposed to have it finished this year, and it's less than like a mile and a half away from. You'll see it actually when you drive in. They've been working on it for 2 years, and they cannot work through the legal stuff because it's on state land. But once that gets up and going, we'll have high-speed 5G, all that kind of stuff out there. Now, if you got AT&T, you're probably going to be okay. I think Verizon was pretty good. The T-Mobile slash whoever they were before.
They're Metro.
Yeah.
It's
So
it's trash. It does not work.
yeah, and Anita will know because she went to New Mexico State and knows the area better than anybody. Yeah, it wasn't mine. Mine was not good at all. But I had another phone that was AT&T, and that seemed to work okay. So again, if you're using a cell phone to do your GPS and mapping and that kind of stuff, put it in airplane mode and see how well it maps, because that could be one of your challenges. Understand some limitations that are out there. Next year, hopefully that will all be resolved and everybody will have some super awesome cellular connectivity. But again, practice. Let's load that into the body tube, and I want to see how it anchors in there. How do you keep it from sliding all around and stuff?
Okay. Yeah, I can give me 1 minute. So I guess I will preface this. This is kind of one of our, since we're one of our big learning points. This is going to be sandwiched in the coupler here with our switch ports. So it's going to be a little bit of a process. Just give me 1 second.
What are those 4 holes?
These 4 holes are for our switches.
Okay.
So they'll be accessible from, well, if you could see it, they'll be accessible from the outside. They'll be our charge safeties up top, and then our computer safeties. So that when all 4 of them are off, we have 2 independent ways to prevent premature ejection.
Gotcha. So rotary switches, I like them. I've used them. Again, religious values are different between Rocketeers. One of the things that people aren't going to like about them, and this is one of the things I've actually been burned on, when you put one of those switches through your body tube, they actually extend fairly far down into the body tube. And what can cause some real challenges is when you're sliding your eBay in and out, bumping on those connectors. So if you take that switch, that rotary switch, flip it upside down the camera and look at the metal connectors on the bottom of it. So you see how small those are? There is nothing to those. How hard would it be to bend one over and snap it off?
Pretty easy.
Absolutely. And so they're pretty thick as well. I mean, when I say thick, I mean as far as they go down into a tube quite a bit. And when you add the connector onto the bottom of it, I mean, gosh, now you're going down into the tube 2 inches, 2.5 inches. So when you're doing that and you slide that eBay in and out of the tube, you could snap one of those off and not even know about it. And that's not a good day. So be real careful with those. And I've also had rotary switches just fail on me for no reason whatsoever. Got a bit of sand in the wrong spot, and all of a sudden it's non-functioning. So spare kits, spare parts kit that you want to take with you, I'd have 3 or 4 of those with you.
Definitely. Sounds good.
Okay. All the interconnects for your electrical wiring, are you planning on throwing some tape around all those when you connect them?
Yeah, we're gonna need to go through and just make sure all those connections are
Yep.
nice and secure.
Very good. All right, so let's see how the eBay gets, I guess, how you keep the eBay from sliding around inside the body tube.
So, what we'll end up doing is we'll be disassembling this. There is one component that we're still waiting on being 3D printed. I believe it's already made. We just have to pick it up. I'll explain it here in a second.
Sorry, the other thing on the those long nuts that are going through for the electrical connectors, you want to trim those off. You want to make sure you don't have too much excess lying out there. On the inside of eBay should not be a big deal. But if you ever have anything on the other side that loves connecting with parachute shroud lines and all sorts of other problems. But again, just as good practice, if you've got that going through, you don't want it to extend too far out.
So the part that I mentioned that we're kind of waiting on, there's going to be a nut, a specially made nut that's going to go here that'll make this whole piece one component. Right now, everything's kind of loose together, so that'll be snugged up for the final version. But we took this plate here, and it's sitting up against the end of the coupler in this tube. And what we are going to do as part of our checklist, we'll make sure all the threaded connections are Loctited, and then these are going to slide together. It's kind of a hassle right now to go through the full component, so I'll just kind of walk it through.
Yes, so we can't, slide it towards the camera because we're not seeing what you're doing.
Just had to reposition myself. I'm going to switch it back over to the mobile one. So eventually this will be sitting up against the edge of the coupler. This this diameter is less by just a little bit than this OD for the coupling tube, so we won't have any fitment issues from the sliding part, but it will rest flush against the edge of that coupler there, and then the all thread are going to compress it into place.
I got you. So the coupler itself will be basically the walls of your avionics bay.
Correct. It's essentially like an integrated avionics bay. That's kind of one of our lessons learned from this that we're going to be passing on, is to make sure that AE bay is a separate.
So let me throw out another tidbit lesson recommendation. Having the that lid that you're talking, that section that's right there on the camera, just flush up against the body tube, sounds easy, but when you're in the middle of the desert, the wind's blowing, you're hot and sweaty and frustrated, a lot of things can fail to line up properly, and you tighten it down and that thing's just not playing nice, and you try to insert it into the other section of the rocket and it just fights you over and over and over again. You can quickly fix that by, if you just pull that section out from the body tube just a little bit, and if you added a second ring, it doesn't have to be as thick as the first one. But, or even if you, I don't know if you want to do that or not, but add a slightly smaller second ring on the inside of that, that does actually go inside the body tube. When you slide it in, it will nicely fit, it'll fit nice and snug into it. And that way you can sort of sand it down and ensure as long as it's snug, it should fit into the rocket. You don't want that thing giving the opportunity to just slide left or right, up or down. And if you put again, we'll call like a smaller version of that, creating a lip, it will ensure that connects perfectly with the other side, and won't get out of alignment. I'm hoping I'm explaining that correctly.
Yeah,
You
that
guys
makes
understand
sense.
what I'm saying?
Mhm.
That makes sense.
Yeah, because if you're expecting it to fit flush against something without, somebody bumps it the wrong way when you're walking it towards the other part of the rocket, or as you're sliding on the rocket, the thing shifts a little bit, and all of a sudden you got all sorts of pain and suffering. It's much nicer if you can slide it on, close it up, and it's going to go straight in the rocket without any problems.
Definitely agree. That's a good idea.
And do that on both sides.
Yep.
Yep.
All right. Anita, anything else on that?
So as you guys are, getting it really tight, do you have any concern of that lip meeting your edge of your coupler and creating a tight seal?
No, we didn't have any concern with it. The water jet did take it like a couple thou smaller than the OD of the coupler tube. So no, we don't have any big concerns, and we were probably also gonna, we read out there some of the other teams are greasing the coupler sections. We might give that a shot too. I don't know if unless you had any feedback on that.
I've never personally used grease to ensure, I guess, pressure, but previous experience just to make sure that edge of that lip into the body or into that tube. I've used aluminum tape and it's worked really well in making sure it has that pressure and there's no gases escaping in or out of that tube.
Gotcha. And you said aluminum tape?
Yep.
Yeah, you can use almost any type of tape, just depending on how big that gap is. But the key piece is when the sections are connected together, there should be no play. So if you grab the top, you grab the bottom, and the two people that are holding each section, and that is going to be something that's pretty critical. If you get wobble, there's going to be leaking, there's going to be other problems.
Right. Yep.
Another reason to put that second bulkhead, that smaller bulkhead on each side, that'll make a stronger air seal. And again, ejection charges firing on one side versus the other. You want to make sure that the pressure inside that body tube, if it goes inside of your E-bay, you're going to have a main deployment at apogee. And that happens to so many teams, I cannot stress how often that happens. Very, very painful lesson. And your recovery goes from being maybe a quarter mile to a half mile away to being 4 or 5 miles away type scenario when you pop your main at 10,000 feet. So, especially if it's a windy day. So you want to protect that avionics area and make sure the only way the air pressure can get in there is through those vent holes on the outside of the rocket. Again, if any pressure from those ejection charges manage to sneak inside that avionics bay, you will basically see you'll see both sides of your rocket eject at apogee. Not fun. Let's look at your vent holes real quick.
Okay. So these are the big holes are obviously for the switches. There's the holes for allowing the atmosphere into the E-bay. Those actually have to be upsized to a 5/16 based off of the user manual of the RRC3 mini, so those will be a little bit bigger at competition. And then we have an 1/8-inch hole on any compartment that could become pressurized and cause issues.
Good
Just
idea.
from the changing altitude.
Vent holes, you might want to go a little, maybe even a third vent hole on the other side if you wanted to.
Okay,
Never hurts to have, we've seen crazy large vent holes, which are unnecessary and potentially are susceptible to wind blowing, which is always exciting. But your switches are going to be permanently mounted, or are those going to be sort of in and out when you have to?
for the sake of competition, they will be permanently bonded. There's the thread, oh, see it. There is a threaded portion right there.
Yep.
And there is a backing nut that will clamp into this.
Okay. That sounds good to me. All right, Anita, anything else?
Not for that bay, but you want to look at the parachute specifically?
Yeah, give me 1 second to kind of clear off some of the stuff.
Okay.
All right.
Guys, at the end of this, I don't know who's responsible for it, but if you could please send me a link with the video so I can download it. I want to make sure that we get the video uploaded to our social media.
Sounds good. We can do that. Eli, you want to take it away?
Yeah. So on the left there is our drogue parachute. It is about a 3-foot diameter. It's kind of squared, so it's hard to really give an exact number. And on the right there is our main parachute. It's about a 10-foot diameter parachute. And these are bought off of Rocket Man parachutes.
What color is the drogue? I just see the blue. I'm assuming that's part of the shock cord, but
It is a blue and black, I believe.
okay, cool. So definitely 2 different colors. Love the bags. Good protection.
Yep.
Okay. I'm assuming they're brand new, or at least that drogue looks really brand new.
Yep, they're both brand new. Haven't used
Okay.
them.
That's fine, but it's really tight. I would let both of them because I'm assuming they've lived in those bags since you guys have gotten them.
Pretty much, yeah.
Yeah. So they'll actually stay retained to that shape. So maybe drape them and let them breathe a little bit. I recommend throwing, like, every time we get a shoot, brand new or not. Actually, I would wash the shoots, but not after a launch. But I stick baby powder or something to that so it won't stick to itself. It actually helps it more, like, not stay to itself. So let them breathe a little bit, and so they will actually open in flight.
Sure.
Or better chances of that. Okay.
Sure. Thank you.
So what is going to pull the main out of that bag? Do you have a smaller sort of mini chute that's going to come out, or are you expecting the ejection charge just to pull everything out?
We're expecting the ejection charge to pull everything out.
How tight? I mean, it doesn't look very tight in there. Is it, when you get it all packed up, is it, I mean, just, I would do a quick, if
Here, give me
you
1
can't
second.
easily pull it out
Yep.
with very little force, then you should be fine. If it takes a little bit of oomph to get it out, you may want to consider a smaller parachute to help.
Yeah, so when we first got them, we packed them in the bags and then messed around with pulling them out of the bags, both parachutes, and they both came out pretty easy. So
Are you guys attaching those bags somewhere inside? So we've had a team previously, it'll be in the bag, but literally there's no tension pulling on the bag. So your chute and everything are just going to go along with the shock cord, so that chute never clears or even opens, releases from the bag. Have you guys considered maybe that as well?
Could you further explain what you mean?
So when it was wrapped up in that inside that parachute bag, right?
Mhm.
So I'm assuming when you guys are simulating pulling one end of the shock cord out and that's living inside a tube, does it all come out, like I like to call it a burrito? Does it all come together? And does it ever separate from the bag by itself?
So when we were messing around with it, we didn't tie it to the bag. I believe the parachute's going to be tied to the bag somehow.
So the parachute, so basically you need that bag. Usually on top of the bags, there's a like an anchor hook,
Yeah.
there's a hook.
Yeah.
Hook that to the top part of your, wherever it's deploying. So one of your hard points, that's the best friction or like the best anchor point. And the rest of the shock cord won't hold it completely. It'll hold everything there and it'll be your anchor point. So that top loop, if you have your hand there, you'll hook it with a swivel link or some kind of connector link, and your chute's going to rip out of there. It gives it something else besides hopefully the air to pull it out.
Okay. Yeah.
Okay. It's like a hard point. So I've seen many failures because of that. So kind of more of a rocketry advice.
Thank you.
All right, we're going a little bit long on this one. Anita, any other questions?
I think that was the last question I had. They answered everything in the presentation that I had on my second progress report. So thank you guys.
Yeah, honestly, guys, for honestly a first year team, this rocket's done fairly well. So I'm pretty impressed. I'm going to spend probably next 10 minutes or so just going over logistics. So I'm going to ask you guys a bunch of questions about your travel plans and trying to get you as quickly up to speed on some of the activities that occur at the Cup, and particularly the fact that none of y'all have been to one before. So, better prepare the team and then answer whatever questions you guys might have as far as, what do we need to do? How do we need to do it? Where do we go? What do we do? So I guess I'm going to kick it off real quick. First question, how many members of the team are going, as far as students, as far as mentors / advisors, and then your flyer of record? Let's see, I guess from that standpoint, yeah, we'll just answer that one.
So we are planning on 6 at the moment, 4 total team members, myself, Eli, Josh. I believe Hayden never was able to join it. It doesn't look like it. So Hayden's the only member who would be competing who isn't here today. Our advisor, Dr. Ash, is coming with us, and then our flyer of record is coming with us as well.
Excellent. Are you guys planning on flying in or driving in?
We're planning on driving it.
Okay. All right. That's fine. Are you staying at a hotel, Airbnb, or dormitories?
Dr. Ash, should we get the Airbnb fully reserved?
Yeah, it's a VRBO.
Okay.
And that's the one in Las Cruces, right?
What's that?
That was in Las Cruces, right?
Yeah, that's correct.
Excellent. Okay, and that's excellent. You get Las Cruces. Truth or Consequences is another option when they run out of hotels, run out of Airbnbs, etc. But Las Cruces definitely is a little bit closer and a lot more. It's closer to the various events and Tuesday and Monday registration, that kind of stuff, closing ceremonies, that kind of stuff. But a little bit shorter drive and a lot more other things to do in the evenings, etc. If you're looking for dinner, that kind of stuff, or if you're looking for supplies, you need extra this or extra that, whatever. So, Las Cruces is a neat town. I enjoy being there quite. She knows it better than anybody. So definitely sounds like a fairly small team. 4 members would be just about as small as I would ever recommend. Essentially, it would sound to me that all 4 members are going to be part of the pad team, meaning all 4 people will go out to the pad with the rocket. Is that correct?
I believe that was our assumption going
Okay.
into it. And so everyone is also.
That's fine.
Oh, go ahead.
No, so same thing for recovery. Probably all 4 members would be on your recovery team as well. To go down range, you must have a AAA membership. It can be a student membership. That should not be a problem. You do not require to have any type of certification level, like level 1, level 2. You just need that $10 AAA membership. Does everyone already have that ready to go?
Yes, sir. Everyone does have one. And then our whole team is level 1, and myself and Josh are level 2 as well.
Oh, rock. That's outstanding.
awesome.
Yeah.
Do you guys actually physically have the cards? That came up a question last night in a review I had. So
No, the students don't have cards. It's just a picture on their phone.
okay, okay.
Myself
Bring that
and
with you.
Josh too, because we have we're too old to get the student membership. We had to get the real one. So I think that might be the breakdown that we noticed.
Ouch.
Okay.
That means
I have my card.
So if you're not a student member, that means you had to pay the big bucks, right?
Yep.
Ouch. Yeah. Yeah, that's what
Yeah,
I get
Andy,
paid.
we're seeing a disconnect with some other teams. Even they got them last year at Cup, like so they got their Triple E certification or their actual, insurance, but they still don't have a card or proof of a card from last year. So there's some questions asked
Well,
around. So
yeah, they're going to have to validate it. And so if they need to reach out to Tripoli or whatever the case might be, we need to be directing them to do that.
yep,
So there
question came
should
up last
be all students, the reason they're not getting cards as a student is the cards and the shipping are expensive. And Tripoli, quote unquote, is losing money because the student membership's only $10. They lose money anyways because the insurance for the students is just, it's significantly more than $10 per person. So, but nonetheless, the students should be receiving a digital, quote unquote, link on their phone that they can pull up and show us that, here's my digital membership card. But it's not a physical card. You only get that when you become a full member, student, senior member, excuse me. So anyway, make sure everyone has those readily available.
Yep.
We will be pre-validating it anyways. There'll be another survey going out here in the next week or so, where I'm asking for full list of everyone that's going, Tripoli ID numbers, and we're going to send it to Tripoli. And if any of those come back saying don't know who this person is, then we're going to have to work through that. We want to avoid last year's registration snafu because it was taking teams 4 hours to get through registration. Second question, liability waivers. Everyone, including ESRA, including even Spaceport America staff members, must complete that liability waiver. So it's at spaceportamericacup.com. It's just a little link on the top, and you have to complete it. And I recommend if you completed it, you should keep the email that you get that's saying you completed it. If you don't have that, just go fill it out again and keep that email. So that way, when you show up, you present that, you present your Tripoli, and things go nice and smooth.
So I did have a note on that. I was looking at doing mine. The link provided in the documents /forms page doesn't go anywhere. But if you look specifically for the 2023 liability release waiver, it pulls up what I would imagine is the correct one.
Okay, well, that's a good note. I will take a look at that one. So you said where is the dead link at?
The dead link, I'm gonna look at it right now, is if you go just to the ESRA webpage, the Spaceport America documents specific page.
Yep.
You go to that, you go all the way to the bottom, or not all the way to the bottom, but you go down to that waiver and you click on it. It brings up a not found post, and it does say that the link is a 2022 waiver, not the 2023.
Holy cow, bad Andy, bad Andy. I thought I updated all those. All right, I'm just gonna valid check that myself. I'm pulling it up real quick. Oh, Lord. All right, well, the maps is in there, that's good. Dun, 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 dun. Risk assessment, abstract, school participation, a release of liability. Oh my God, it's right there. Completely missed that one. Dang. Okay, I'll get that fixed. Thanks for the heads up on that. But again, if you just go to the spaceportamericacup.com, it will take you, the very first link on the very top is liability waiver. Click on that and you should be good to go. But thanks for the heads up on that one. While we're looking at that one, that's a great resource here. Eeny, meeny, miny, mo. So let's look at, there is a section in there for proper clothing for Spaceport America Cup. You guys need to review that. It is when you go out to the vertical launch area, we'll refer to that as the VLA. That's the desert. That is actually on Spaceport America grounds. It is New Mexico. It is dirt, dust, rock, cactuses, sticky bushes that will make you bleed. There's a lot of nasty, harsh stuff out there. It's very beautiful. There are tarantulas that only come out at night, which are really cool. There are also rattlesnakes, and they don't typically come out in the day very much at all, but still, there are potential, don't be looking under rocks and going into their hiding spaces because that's not good. There are various different, what's the other thing I'm thinking of? The, shoot. Anyways, the document has all those scary things in there. Clothing wise, tennis shoes, absolute minimum tennis shoes. Hiking boots, fantastic. You wear a pair of slippers or a pair of any type of slide-on shoes or anything that's not a true protection against bad stuff, you will get sent back. Basically, go home, try again. Highly recommend pants. Blue jeans are fabulous. Any type of canvas kind of things are great. No shorty shorts. No, I wouldn't do shorts in general at all. If you do go, especially if you're on a recovery team and you're out there and there are bushes that they look fine, but you rub up against one of those with shorts on and you're going to come back a bleeding mess. Even sometimes with pants on. I had one of those thorns, which can get upwards of 1.5 inches to 2 inches, go through the bottom of my hiking boot and stab me in my foot. So I'm just saying, be real careful. The sun can be extraordinarily hot out there. Some years, 2017 was one of the hottest ones we ever had, and that reached temperatures of about 114 and was just typically over 110 every single day. No humidity. So you will be parched, dry, lips will start cracking. Sunburn potential is through the roof. Baseball caps are cool, but they don't protect your ears. You need something to protect your head, some type of floppy beanie hat, that covers everything. Anything that'll cover your neck is even better. Hands, anything that's exposed to the sun, forearms, that kind of stuff. If you do short sleeve shirt, I wear long sleeve shirts. Yes, it's hot, but the long sleeve shirts will protect your arms and keep your arms from getting burned. I can still get really bad burns on your hands. So, I'm slathering up my hands 3 times a day typically. Drinking water, cannot repeat it enough. We do not provide any refreshments, any food, anything like that to the student teams. We're lucky to feed ourselves. But there are food trucks that will be out there, but student teams are highly recommended to bring ice chests, bring lots and lots of water, more water than you can imagine. I would highly recommend that everyone, potentially drink a gallon or more of water a day while you're out there. When you start to experience one of the worst headaches you've ever had while you're out there, you probably will. When you feel a headache coming on, that is your first sign of severe dehydration. And chugging a bottle of water will make that headache go away in about 10 minutes. If somebody else is complaining about a headache, anybody else is reacting very strangely and not answering questions and not really focused. The good thing about Spaceport America is we have a level 2 trauma unit on site with off-road capable ambulances. We have life flight highly available. So they supposedly can do open heart surgery out there. And the hospital that sets up this is their training exercise every year. 90% of the problems that we run into are dehydration or sunburn. So avoid that. If you've never been into a hot deserty type of environment, the student teams from Australia were just amazing. They showed up and they were teaching us how to survive in the desert. Because they showed up and there's like, this is just like home. Crazy hot, super sun all over the place. Last year we wasn't too bad because we had a day of rain. That's the first time we ever had one of those. And I think the hottest temperature we had last year was about 95 degrees. But I cannot promise anybody that. That was definitely an exception. So pray we have hot weather because that keeps the clouds away and that keeps the water away and we can launch. Either one of those two things, water or heavy cloud cover, will keep us from launching, and that means you guys might not get to launch. So download the document, take a look at that one, understand it very well. The next document underneath it, maps. When you leave Las Cruces to head out to the VLA for the first time, if you pull up Google Maps and just type in Spaceport America or you type in VLA, it's going to send you on a goat path on a mountain, probably the wrong side of Spaceport America. And you won't figure it out until you're trying to figure out how to get back to Las Cruces. The maps through Google Maps, iMaps, even the Microsoft Maps, they are not updated. They are not correct. They will send you the absolute fastest way that you can get there instead of the correct way. So download the appropriate map, print it out, keep it with your important documents. The first day you drive out there, it's at least an hour drive, maybe more. So you want to be prepared. Gates open at 6 a.m. We used to open up at like 5 and 4:30 for the gung ho teams, but that's just crazy. We stopped doing that. So 6 a.m. the gates open. There will likely be a line of cars if you get there at 6 a.m. Just you'll have to deal with it. When you do show up, you need to have your badges. We give you guys badges and car passes and a bunch of other things. You have to wear those at all times, even in the convention center area. If we don't know who you are and we can't validate that you're part of a team or a mentor or advisor or somebody like that, we'll ask you to leave. And so you don't want to forget that. If you're halfway out to the VLA and you're like, oh crap, I left my badges in the car or in the hotel room, turn around and go get them. Because when you get there, one of the great things also Spaceport America has is an incredible security team. And they used to be ex-military SEALs. Excuse me. I mean, they used to be some real gung-ho kind of guys. So don't mess with them. Don't give them a hard time, particularly around badges. They will eventually let you in once you can validate that you're actually a member of a team. If you've lost your badge, you will probably have to come see me, and I'm going to make you suffer. So be very, very, very careful with those badges. Just keep them in the car if you have to, so that they don't get lost. But whatever you do not leave the hotel unless you know exactly where your badge is, because you'll need it whenever you're coming out. Monday is registration. When are you guys planning on arriving?
I think our travel plans were driving down on Sunday, arriving Sunday night.
Excellent. So that is definitely appropriate, totally understandable. Monday morning, 10 a.m., the doors open. And so another great document on here, if you scroll back to the top a little bit, is the integrated master schedule. I would typically wait until about a week before. We are constantly updating this and making minor changes and that kind of stuff. No matter what other information you see anywhere, that integrated master schedule should be the 100% bona fide correct. So you want to make sure that maybe a week before the cup, download that document and make sure wherever you keep your important documents, that you follow that day by day. It will walk you through all the activities occurring. Be prepared for activities coming up the next day. Great example, Tuesday is convention day. Well, it's also opening ceremonies. Opening ceremonies start at 7 a.m. So if you show up at 8, you've already missed a whole bunch of stuff. So it's an early morning start on Tuesday. Monday registration starts at 10 a.m. and you have a lot of activities taking place there. So be prepared for all of them. Number one, you're going to register, make sure all the fees are paid. You'll go through a couple of checklists here and there, and we'll make sure all of the members are Tripoli. Your flyer records has his Tripoli card. You know, all of these things are checked off. You'll be handed badges. Everyone will get their badges in their neck loop and all that you need to do. One of those will be a team photo. And so we'll have a photographer there that will be taking team photos. So if you have team shirts, wear those. And so if you have your rocket there, you know, have it with you, etc. That's all fine and dandy. You'll also be doing your range safety inspection. First opportunity for you guys to have your rocket inspected. If everything goes great, you may be ready to fly Wednesday morning, which would be, you know, fabulous. If you can get signed off, you're in great shape. If they find issues that need repairs, you'll have until typically, hopefully you'll have them done long before Friday. But the quicker you can get those repairs completed and resubmit your rocket for inspection, the quicker you'll be ready to prepare for your launch. That's Monday. At the rocket in your hand, team with team shirts, and we're all going out to the parking lot and we'll do that mass photo. Hopefully you guys have seen that photo. I think it's somewhere on the ESRA homepage too, but you've probably seen it before, and it's yeah. So it's right on that homepage. So super important to have everything there. That usually takes anywhere from 30 minutes to 45 minutes or so. So we'll get that photo available, and then you're free for the rest of the evening. Go visit, go, you know, you'll spot on the basically Visitor and Convention Bureau for Las Cruces. If you wanted to know what to do, you know, in the evenings, where to go eat, you know, what kind of cultural things to go, what kind of rocketry museums, there are some fabulous rocket museums there. White Sands Missile Range is, their museum is, you can actually lay hands on an actual V2 rocket. You can't do that anywhere else in the world. So lots of opportunity there. They'll answer all the questions that you might have and give you some free ice cream too. So that's a winner. So that's Monday. Tuesday, you'll turn around, show up at, you know, I plan on arriving around 6:30. The parking lot situation there is it's not going to be able to handle 1,800 students. We're planning on estimating about 1,800, maybe 120 to 122 teams. It'll be a record. It'll be the largest competition we've ever held. Parking is going to be a challenge for everyone. You're allowed to bring in your vehicle that has your rockets and your supplies and that kind of stuff to the convention center. You can unload it at the loading dock, or you can just drop it off at one of the sidewalks. You will not be able to park your vehicles in that parking lot. There is another student parking lot that you'll be directed to about 2 blocks away. You will park there and then just make your way back to the convention center. Again, same scenario on the way out. You would go grab your car, bring it around, and put all your gear in it and pull out. That applies for both Monday and Tuesday. That'll be the last activities that you do at the convention center. Wednesday morning, you can show up as early as 6 a.m. if you'd like. You'll be directed to the student area, prep area. Every team is given a 20 by 20 square foot area. Recommended that you bring some type of canopy to protect yourself from the sun and the heat and all that. Tables and chairs will not be provided. You will need to bring those yourself. International teams will typically try to rent them from somebody or borrow them from somebody, or if worse comes to worse, they actually go and buy them and then just leave them. Let's see, for you guys, if I'd bring, whatever tables and tools, and there's no electricity out there either. So if you do need electricity, we recommend bring a very small generator and only use it when you need it. Please do not be running it nonstop. The teams are all jammed in together. 20 foot by 20 foot is a fairly decent space for 4 people, plus the advisors and such. There are food trucks that are out there. Again, you can buy food from them, or you can bring your own. Anita has, in her leading of the New Mexico State team, would often, the whole team would just get sandwiches at Walmart or wherever and be able to bring them in their own ice chests. But if you want to purchase through the food vendors, you can do that as well. They're food vendors, similar to like going to a movie theater or rock concert. They won't be particularly cheap. So let's see, I'm talking a lot. What type of questions do you have for me up to this point?
I did have one question concerning maps. I don't know if you've gotten a request for it yet, but is there any way to get like a geolocated map that we can use on like mobile apps that don't require internet, for example, Avenza?
Well, I know. I'm not sure. You might need to follow up with me later on that one. Because I'm just thinking of some of the other applications that I've used that allow for downloading. But I know inside of your Telemini, so the Altus Metrum software, you can there's actually a drop down for Spaceport America. And you can drop down and you can get all those maps preloaded before you start tracking it. Actually, the Telemini doesn't even have the GPS, so that's not going to help you. Huh. Yeah, follow up with me on that one after this review. I'll have to shoot that one off to some of my experts. Anita, do you know anything about being able to do something like that?
Not entirely. I think one year we actually made our own UI and we connected. We downloaded the area on Google Maps and we were able to do it that way, but it took a long time, so it wasn't the easiest integration.
Gotcha. I do know the Altus Metrum software, even though you're not doing telemetry on yours, I know that at least will give you maps that you can look around. I don't know if you can type in GPS coordinates because it's supposedly specifically linked to a telemetry enabled altimeter from their product line. So, all right, good question though. Again, follow up with me and I'll see if I can find somebody smarter than me that can answer it for you. All right, any other questions? All right, I'll keep going through the week activities. So Wednesday is a setup in the morning. We typically won't open up the flight line until about 12 noon. That's, we're doing final testings and checkouts and ensuring all of our systems for launch operations are up and running. We've got a live stream going, so a lot of activity going around there. You're going to probably get interviewed at some point in time. If you guys have any social media people or anybody that's interested in putting together a quick introductory video, a 15 or 30-second little clip saying, hi, we're team 123 from Snigglefritz University, and our rocket is called such and such. It's in this category. A real quick sort of rundown. Any team that submits a video like that to us, we will definitely run it on the live stream. And the whole idea is when the live stream is running and your team is heading out to the pads, it's like football players coming out of the football field. We want to run that video while you're heading out there so that everybody at home can see, oh my God, that's my school. I had no idea they were even competing. So that's the general idea. Longer video clips would definitely be cool as well, where you introduce maybe team members. Here are the 4 people on the team. Here's our advisor. Here's a shout out to our sponsors, et cetera, et cetera. So any of those video components are a great investment. Typically fairly easy to build, but very few teams ever do it because it's not a rocketry function. But it is very, very important for helping secure funding years future. So if you can fly Wednesday afternoon, you get bonus points. Win-win. If you can't, if you got security safety issues, whatever the case might be, or there's just too many people in front of you and you have to fly the next day, that's perfectly okay. No worries there. Flying on Wednesday and Thursday, fantastic. If you're able to complete your flight Wednesday and Thursday, get yourself a pat on the back. I mean, that is success. Even if your rocket is completely successful, I mean, that's time to party. That's where, fantastic, life is great. You may not have had perfect numbers, you may not have hit your perfect altitude, doesn't matter. You want to get that rocket back as quickly as you can through the recovery process. And then once you do, you'll bring it to the data recovery tent, and we will validate your altitude, your actual altitude versus the one that you estimated. Before you fly, you will have to write down what your estimating altitude would be. Some of these teams will just say, well, at home it was this, but the good teams that are really good at this, they bring in all the variables that are taking place that day and go, run it through a simulation, run it through 50 times, and the averages that are coming out, they run every variable. And these are the teams that usually can get within 50 feet. Some of these teams get lucky and get well within 10 feet. The winning team last year, I think, was 8 feet off of their mark. Obviously, part of that's luck, but part of it's not, because it seems like it's same teams almost every year that are coming within, just a few dozen feet of their target. Whereas other teams are sometimes 1,000, 2,000 feet off. But that happens. You learn and get better the next year. So if you can, again, fly, if you're pushed to flying on Friday through where it's a safety issue, whatever the case might be, get it done. If you unfortunately find yourself in a situation where you have to fly on Saturday, we cannot guarantee anything. We tell all teams that flying on Saturday is a roll of the dice. You may get to fly, you may not, because we shut down at 12 noon on Saturday. We have a lot of cleanup to do. We have to give the airspace back to White Sands Missile Range. And keep in mind, you guys are flying in White Sands Missile Range, so they literally have to shut down Department of Defense projects for 4 days for us. And so there is, it's pretty challenging to get them to do that. But they need it back as quickly as they can. So, we're lucky to do that. We don't want to mess that up and have them say, forget it, we're not going to do it anymore. But we do shut down Saturday at noon, and that's a hard stop. So even if we have potentially 2 rainout days, which would be a horrible nightmare, we cannot extend into Saturday afternoon. We cannot extend into Sunday. These folks are waiting for, F-14s or F-18s to come flying in and dropping a bomb on some target. And there are multi-million-dollar projects going on that are waiting for us to finish our stuff. So again, that is sort of the hard restriction. And we've always had fantastic weather. I mean, it's been very hot, but last year was the first year where we actually lost a day. We lost Wednesday to rain. And hopefully it won't happen this year, but there's always a possibility. Saturday, if you've flown on Thursday, Friday, or Wednesday, Thursday, and you really don't absolutely have to come back out to the VLA, but if you want to come out and help some of your teams watch some of the other rockets launch, that's great. If you want to cruise into El Paso and go to the water park, that's cool too. But we do ask that you please show up to the Saturday awards ceremony. This one will be in the, I guess, 6 p.m., 7 p.m. It's on the schedule. And this year it'll be at the Pan American Center. So we'll have a lot more elbow room. We won't be packed in like sardines. But it'll be neat because we'll be able to watch a lot of the cool videos on the Jumbotron that they have. And it's always sort of frustrating and a little embarrassing when you may not have done well. Your rocket may have had a lot of challenges, but you didn't know this, but you might have won a sportsmanship award, or you might have won, one of the poster the poster session or the presentation awards. Who knows what kind of award you potentially could have won. And when they announce your team's name and no one's there, it's not pretty. So, and it's a lot of fun there. We'll be selling swag for the first time. So for team members, family members, anybody that maybe wants a sticker or a patch or a shirt or a cup or any of the neat stuff that we're going to have available. This will be the first year that we'll have that. So that will be available as well. And I think we'll do obviously cash and credit cards and all that other kind of stuff as well. So looking forward to that. Anita, what am I missing?
The border check from
Good one. Okay,
yes.
go ahead.
So there's a border check going from Las Cruces to the VLA. The one question they're going to ask is, everyone a U.S. citizen? If you're not, just have the proper documentation for it. Your rocketry badge with you as well. They are aware that spaceport is going on and tons of vehicles loaded with rockets and equipment and stuff are coming through. Just be respectful and listen to them, and it usually goes very smoothly. So keep that in mind. I think everything else you covered.
Yep. All right. I'm just looking at the notes real quick. Oh, okay. So talking about Duncan's talking about the Adafruit 1S batteries. I don't know, Duncan. I'll have to talk to you about that one. That one, I had problems. Anyways, Duncan is a Embry-Riddle student who is one of our interns. So he's been flying rockets with me since he was in first grade. So he's got some expertise. He's also our lead drone expert. So if any of the student teams are interested in doing any media drones or anything like that, they need to report to Duncan for that. So Connor, you mentioned the I-25 exit, all that. The road from that takes you from I-25 to Spaceport America, it's a great road. I mean, it used to be a dirt road and you'd get a flat tire and you'd be trapped out there and it'd be terrible. Now it's a beautifully paved road, very, very nice, but they put a 45-mile-an-hour speed limit on it, which just drives me crazy because I'm from Houston and we drive like NASCAR. So what I'm saying is, it says 45. The cops will be on the road. They're really good at hiding. I about had a coronary last year because I was doing 65, somewhere around there maybe, and I come around the corner and there's tons of turns all over the place, and there's a cop car sitting right there. I just pulled over. I knew I was dead meat, and pulled over, and the cop car didn't move. I'm like, what's going on? He never pulled over. He had parked his car there and then left. So it was an empty car. That was rude. Nonetheless, be very careful with that. Drive safe. Do not drink and drive. Be careful of the partying. We want to make sure that everyone comes home safe always. So, the evening time activities, Las Cruces is a very safe city. Some cities not so great, but Las Cruces is definitely a good city. New Mexico State campus is there. Lots of neat stuff to go visit and other functions. Try to limit the drama. Last year we had all sorts of drama. We had girlfriend-boyfriend drama that the boyfriend broke up, girlfriend wanted to kill herself. Just let's not do that, especially at 3 a.m. in the morning, because whatever you guys do, somehow it will make it just through the fire department channels, it'll make it through the police channels, and somebody will mention Spaceport America, and it'll go to Spaceport America, and then they start calling us. And so we had a young lady that got trapped in some mud because she took the wrong trip, and instead of staying with the car like she should have, her cell phone died, and so she just decided that she's going to get out of the car and start hiking to Spaceport America. 10 miles in 12 hours. And we had every man hunting kind of party, the sheriff's office, helicopters flying out, and couldn't find her, literally could not find her in 12 hours. And then finally her team sees her walking up to the table, and so holy cow, let's not do any more of that. That was not fun. So manage your drama internally. Do not damage the Airbnb, because it will come back to haunt me and the ESRA and Spaceport America Cup, and eventually your team as well. So if you're doing repairs in that Airbnb, just, you're not a big team. Don't try to stuff 19 people into 3 bedrooms type of thing. So just be smart. You got your advisor with you, so I'm not worried about that. That makes me feel a lot better as well. So if you got questions, ask. Make sure you get on HeroX, use those resources, ask those questions. There's plenty of Walmarts and other places that you can get whatever resources you need. And just be prepared like you're going out to a normal rocket launch. This one just lasts a couple more days than normal. All right. I think that's it from my side, guys. Any questions that you have, don't hesitate to reach out. Post them on HeroX first, and hopefully somebody else will answer them before I have to. But if you run into any urgent issues, I think at some point, Dr. Ash, we're going to have an advisor meeting. We're trying to get a steering committee put back together, which was typically all the academics. And so we'd like to try to get that reformed if possible. And we seem to be having a fair number of advisors this year, so that's fabulous. And guys, great job on the review. I'm pretty impressed. I'm not concerned at all with any of those things. And if you guys can resolve the little things we talked about, I think you'll be in good shape for getting a green check mark on Monday, which would be fabulous.
Awesome. Thank you, Andy.
Thank you.
Thanks, everybody. And looking forward to seeing the team. And thank you, Anita and Duncan, also for joining us. And we've done a lot of these. They're almost getting exhausting up to this point, but we appreciate your patience with us as well.
Thanks so much for your input.
All right. Thanks, everybody. Take care.
Yep, you too.
Bye.
Bye.